Hi, everyone. I'm Jim Cahill, and this is another Emerson Automation Experts podcast. Today, I'm joined by Ashwin Kannan to discuss the challenges for valves used in polyethylene and polypropylene production processes. Welcome, Ashwin.
Hey, thanks, Jim. Nice to be on the podcast.
Well, it's great to have you joining us and sharing some of your expertise with our listeners. Well, let's get started. Could you please introduce yourself and provide some details about your background?
Sure thing, Jim. For all of you who are listening to this podcast, I'm Ashwin Kannan. I'm the global product manager for the process ball valves, which is a brand we have Emerson KTM. This is a key product that is used in the product discharge systems. And in my role, I have an opportunity to meet most of the end users in the polyethylene and polypropylene businesses and understand their pain points and give solutions to them. And that's one of my primary roles in this company.
Well, those are some very important products in the world we live in today. So can you tell us about the production process for polyethylene and polypropylene?
Sure. So polyethylene and polypropylene are probably everywhere in the day-to-day objects that we touch and feel, right from all the packaging foodstuffs that we get up in the morning and touch, to all the plastics in the cars and whatever we see, there is plastics everywhere. So polyethylene and polypropylene are mostly used in packaging industry and also in automobile industry, right? So these are pretty critical component that we really need in our everyday. And these are produced from the basic components of ethylene and propylene. And there is a polymerization happens with the ethylene and propylene, and based on which these are produced.
Okay, yeah, it seems like it's throughout our world and very important products that are made there. Now, understandably, I can imagine that most valves don't survive in this application. It's a very difficult application. What are some of the most common failure modes?
So if you look at the polyethylene and polypropylene, these are, when they produce, they are a coagulated stuff, very semi-solid. But as soon as the heat is lost in the process, in the reactor, it becomes solidified. And they go through a series of isolation valves, especially the ball valves that we have. And these are going to be very damaging. And there are different kinds of processes involved in it. One of the process is a gas-based process in which the polyethylene and polypropylene are produced. And in this process, there is no lubricating media. Right? So if there is a metal-seated ball valve that handles without any lubricating medium, it's going to be a bit abrasive process that the valve have to go through. So the abrasiveness of this media is one of the challenges that the valve manufacturer has to handle. Apart from this, the process itself is very fast-acting and high-frequency application, right? So when I say fast-acting, it is less than 1 second per inch of a valve. So that means it's very, very fast for a valve. And if I take frequency of operations, it might go up to about 600 cycles per day to anywhere between 200 to 600. That's how the end users operate these valves per day. So it's a very, very highly frequently operated. So you have abrasiveness, you have high cycle and high frequency, and then you have high reliable amount of time that this valve needs to operate. So all this put together, you will see that the challenges that this valve can have, and the most common mode of failures that we see in the sites is if there is less engineering work that goes inside, it's pretty difficult for it to really work on the abrasiveness.
Okay, so it sounds like it's a very challenging application for valves, but why does this application matter for the overall performance of a plant?
A good question, sure, Jim. So if you look into the polyethylene and polypropylene production process, these are some of the valves that come at the very last of the end of the fag end of the production of the polyethylene and polypropylene process, especially the powder discharge system valves. It's more critical because that's where our customers, Emerson customers, actually produce the end product, right? So these are the valves that actually takes care of the end product itself. And what it happens after these valves downstream of this is that the polymers are just added some additives, and then it is pelletized and it is backed. So it's almost a penultimate process of our customers. So if anything goes wrong in these valves, the customers have to answer to their customers because they have commitment on their deliveries. So any failure of this equipment is going to cost a lot of money to our customers. And the ethylene, which is a key feedstock for this, is also not available cheap because if you know, the basic building block of ethylene is not really a process or a chemical that you can get it as a byproduct of a refinery. You have to crack it from ethane or naphtha. So a huge amount of process or investment happen for the feedstocks to be produced. So any batch process that has been produced and we are not able to get the right quality because of our equipment failure, we are talking about millions of dollars that has been lost to the customers, so to our customers. So it is very, very critical for these equipment to work reliably.
Well, you certainly described a very high-stakes situation since it comes at the end, right before product is, ready to be finished and sent off to customers. So, yeah, I can understand how critical that is. I guess since it's a critical application and also very challenging for the valves, what do we do as Emerson to help our customers solve this challenge?
Yeah, it's a good question. So if you look at it from Emerson's solution point of view on this critical applications, we don't approach this as a valve issue, right? So we as an Emerson having all the solution integrated, and we talk about this as a solution to the customers, right from the valve, the actuator, the actuation part of it, which is the mounting bracket and all the accessories that comes of it. Because imagine these valves are actually vertically mounted in a 200 foot tower, right? So it's high up in the air. So if there is an equipment failure, the end user has to arrange for a crane or an equipment. Needless to say that they have to do a lot of arrangement prior to this for safety and all the stuff. So getting a valve out of the system itself is a major task. So from Emerson point of view, we don't think that it is a valve issue. We think that it is a complete solution that we have to give. Because if you just go back a couple of questions back, I mentioned this has to work for a reliable amount of time, like reliably work for a long amount of time, say about 3 years, without any failures. So this is more of working of our valves for a longer period of time. So these are automated valves. So valve, actuator, and all accessories need to work reliably for this amount of length of time. So we have engineered these valves and actuators to handle that million cycle times for within the 3 years. So that's the engineering product that we have developed.
Yeah, let's dig into that a little bit. So, you describe this, it's a very abrasive process. How exactly does the Emerson KTM valve solution prevent this powder ingress and component wear to get these multi-years of service?
Sure. So if you look into the structure, so basically we said we have about a valve and an actuator and all the accessories inside this. So let's break it down. And for the valve component, which actually takes the complete media of the polyethylene and the polypropylene, we are going to talk about three areas, right, where the common mode of failures of metal seated valve happens. One is between the ball and the seat. That's where we have a scraper seat design. So basically, the scraper helps to move away the powder which is deposited on the ball side. So as a wiper on a windscreen, car windscreen, right? So it removes the powder so that there is no powder getting in between the ball and seat, and that will prevent the abrasive or failure of the ball and seat. So the scraper helps us to scrape off all the powder deposited on the ball. And then we talk about, since these are trunnion mounted ball valves, they have a spring to assist the seat to be preloaded onto the ball. So the spring is a very, very critical component in a trunnion mounted ball valve. So we need to ensure that the spring is also protected, because in one of these processes is unreactive gases is also inside these downstream of these reactors. So these unreacted gases can go inside these small spring chambers in our valves, and they can actually polymerize inside the spring chamber and can effectively make the valve fail immediately, right? So for us, a dust proofing of the spring chamber is more critical, right? So we protect these spring chambers by providing dust proof. So we have the scraper seats on the ball to seat contact area, and we have a dust proofing on the spring chamber on the body to seat area. And then we have dust proofing on the stem area, because if you look at it, these are gas phase processes mostly, and we need to be cognizant about the fugitive emission, right? So the packing in our design is actually triple layers of protection that we have done. One layer of protection is the dust proofing on the stem. The other one is we have a couple of O-rings on the stem, and then we have a double packing system, which is top. So the packing is way above high. So there's 3 layers of protection until the end user actually sees a failure of packing in our design. So we make our valve design so robust enough that it can handle the abrasiveness and then go for a high wear and tear longevity of the valve.
Yeah, I recall seeing something how, given all these protections in there, testing was done like over 2 million cycles just to verify that it operates robustly, because it's in a high use application where it's cycling all the time. Let's talk about that, the 2 million cycles, and particularly in this kind of application. How did you do that?
Good. So when we started the introduction, we have been supplying our powder discharge system valves since 1990. So, and in 2011, around that time, we introduced a new technology in our dust proofing. We moved from the O-ring design to go to a quad seal type of design, which is having much more sealing points than an O-ring. So when we introduced this quad seal, which is a new technology at the point of time, we wanted to actually do a design validation of this new improved process, right? So what we have done is we put our valve to a testing for a series of testing. So we packed our valve with polypropylene powder inside it, and then we just simulated it as if the valve would be actually going through the process in an actual environment in customer, right? So if we just put an air inside it and then have the whole valve packed, including the cavity area, with polypropylene powders, and then we cycle the valve for about 1,000,000 cycles when we started this introduction of the quad seal in Japan. And in 2020, when we actually moved the product from Japan to China, when we did the whole localization of the product in China factory, we also want to ensure that it is having a reliable nature, that we have moved the product from one manufacturing location to another. But this time, instead of doing 1,000,000 cycles, we also actually wanted to push the boundary to see whether if our valve can be worth enough to go to 2,000,000 cycles. So we pushed our valve to 2,000,000 cycles, and we have fantastic results, phenomenal results. When we open up the valve, we could see the powder doesn't have any deposition on the seat contact area. So that means our scraper seats are working pretty much that we wanted it to work to be. And if you look at it, the spring chambers are completely devoid of any powder. So that means our dust proofing, which I was telling before, is also perfectly working fine with the quad seal technology. So that's where we actually, prove the world that our valve, we just don't only brag about our design, we actually have done some lab testing to be credible about it in front of the customer.
Wow. So it sounds like as a result of all this testing that I guess the customers you're working with are seeing the benefits of this technology. Is that right? They've seen the benefits today?
Yes, of course, right? So since 1990s, we have been supplying. So that tells that some of our customers are still using our PDS valves since 1990s, and they are still getting the benefit out of it. And we have numerous references across the globe, like about 100 reactors around the polyethylene, polypropylene plant are using Emerson KTM valves in the powder discharge systems and working pretty much well.
So I guess for the polyethylene and polypropylene producers that are coming upon and listening to the podcast, and they're considering powder discharge valve technology, what advice would you have to give them?
If any of the things that the challenges to what I told, if you're a plant manager or a maintenance manager or a maintenance engineer, if you're having any kind of problems, which I mentioned, and you're struggling to get a solution, please reach out to one of the Emerson sales associate. I think we will be able to assist you in giving the solutions pretty quickly.
That's great. And I guess as we start to wind the podcast down, what are you seeing in the industry that you think is worth sharing with these producers, that may be listening to the podcast?
So some of the things, the trends that I see is, the polyethylene and polypropylene industry are having a huge demand rise in the Asia Pacific region and the Middle East region. So you would see a lot of projects that is coming up in this part of the world, in the Asia Pacific region, especially India and China, where you see. And what I see is a trend that in the past, when we started supplying the valves in 1990s, the largest size of a PDS valve would have been an 8-inch valve. Then that has gone to a 10-inch, a 12-inch, and nowadays it has been pushed to 16-inch, right? So I'm also seeing the trend that it goes to 18-inch. So all it tells is, as the capacity or the demand increases, the capacity increases, And some of the designs needs larger size PDS application valves as well.
And it sounds like based on the technology and what we're doing to mitigate the issues with powder, scaling up hasn't been an issue in all that, I suppose.
Not at all. Not at all.
Oh, that's great. And I guess this has been a great discussion here. Where can our listeners go to learn more?
I would suggest them to go to the emerson.com, and there is a powder discharge landing page that you can go into. So that's where most of our materials would be. And that's where they go, and call any of our representatives to get more details on the powder discharge system valves.
And I'll add hyperlinks to that page for people to be able to get there easily in there. Well, Ashwin, I want to thank you so much for joining us today and sharing your expertise with our listeners. Thank you so much.
Thanks, Jim. It's been my pleasure. And coming in this podcast and sharing my knowledge with the other fellow colleagues in Emerson and to the plant users outside.